Okay, so for a very hot topic, which I'm sure a lot of people who are dealing with production firmware updates are very, very keen to hear about. So I've kind of prepared a little bit of a presentation. I know it's not our usual style for demos. However, there's a lot of education needs to be done before I can actually do the demo to really appreciate this whole feature. So we're looking at operating system AV updates. So, updating the whole operating system, and also Delta updates. So I'll go into exactly what all this means, and also how it can be implemented. So first, a refresher, in case if you're going, hey, what are AV updates? So we're talking about, so an AV update is basically, you have two petitions, you have a hot one and a cold one, and you switch in between the two to do the full operating system update. So what does that actually mean for a full operating system update? So that could mean, updating the Linux kernel and the device tree associated, so you can kind of access these kind of hardware devices that you have attached to your device. The full operating system, obviously. So, like systemd and all that kind of like your service managers. So that's kind of like the root file system. And obviously the root file system also includes like user applications. So whether they be like containers or, applications you have installed in the root file system. So we're talking about absolutely everything here. So with the AV updates, because you can imagine when replacing everything, things can go wrong. So you want to basically have a usable device at the end, despite whether something, insane happened or the image is corrupt or whatever. So that's basically generally why you have like two petitions. So you have two copies of the whole system. So this could mean I'm kind of like simplifying the whole thing, because you could also have, multiple bootloader petitions and multiple root file system petitions. So it doesn't mean you only have two petitions. It just means you have more than one copy of the functional petition. So when you do an update, you apply to the inactive petition to, do the operating up, the very invasive kind of action to then, stream the root file system. And then you switch to that. But the thing is, because we have two, petitions, we can then roll back if something happens. So if we try to boot in the new petition and it doesn't boot up for whatever reason, then we'll roll back to the previous petition and everything should just function as it did before. And then the update will be marked as failed. So that's the key to the whole thing as a bit of context. But there's a huge, huge downside to this. So with robustness, generally the updates means they're huge, because you have to update the whole image. That might include bootloader or not, or like at least if it's the root file system, these images are very, very large. So in comparison, the Yocto world, so we have an example Yocto distribution, which has thin edge and everything in it. And so it's a headless, so there's no desktop, but it has a container engine, and that comes out at 200 megs. That's actually fairly good, and that's on the small side, comparatively speaking. Because if you look at the Debian world, those images for the same, let's say, user-facing functionality, you'll come out at 700 megs. You might go, well, where's the big difference here? So most of the Yocto stuff, you only put in the stuff that you exactly need for a specific device. So that means you don't get every driver under the sun. You only get what is exactly needed. So it cuts out a lot of the extra stuff that in most cases you might not need. So you have to opt into all of that. So Debian usually comes with everything. Hey, we play nicely with a whole host of like different drivers, Wi-Fi drivers and adapters and whatever. So it might be more convenient, but it is fatter as a result. And if you then go on to, well, what happens if I need some kind of desktop because I have a kiosk mode or something and I want people to, have access to an operating system with the desktop, then you're looking at least at 2 gigabytes. So really, really large images in comparison with, doing a application update, which might be, 10 megs or whatever. So this is where Delta updates kind of come in. We're going, well, wouldn't it be great if we can only send what changed in between an image? So I don't want to kind of get bogged down with details, like if I'm the image creator or something, like what was it, application 1 or 2 or 3 or whatever, like that means nothing to me. So it'd be great if we could just have like a what bits have changed and send them down to the device, because that would considerably reduce our download size, like humongously. So I'm no longer kind of like sending a 200 meg image or a 700 meg image. I'm only sending what changed. But you can kind of imagine what changed is a very open term. So there's many different kind of strategies. I just wanted to talk about two different things. So going in the direction of dynamic updates and static updates. So I have some diagrams to hopefully kind of visualize this a little bit more, but let's kind of like look at some of the rough properties of the two different types of updates. So with dynamic updates, when you build a new image, so a new operating system image, so a root file system, you just have one file system. Like the output of your build process is the artifact that you distribute. So inside that artifact, there's also an index to basically say, what bits do I have, as a very, very dumbed down explanation. So it's just like an index file, which says, what kind of like chunks do I have? Then the device needs to then look at that index. So before it downloads the whole thing, it will download only the index and then do a local comparison to saying, what parts do I need? And we'll only download that. So with such a thing, there is an overhead because it needs to download the index file. It needs to do multiple requests because it'll do like basically X range header downloads. But it's a little bit more complicated, but it's easier for the person generating the image. And it's a little bit more difficult to predict how much will be downloaded. Because again, the relevant parts, the device is deciding this because it has to then compute what do I already have and then compare that with, and then pick out the parts from the image. So that can be a little bit more complex. I won't say it's impossible, but it's at least a little bit harder to know upfront as someone maintaining a device, how much internet quota or like my 3G bandwidth am I going to use when downloading this firmware image. So this is where static then updates come in. So the second kind of technique. So instead of per release, you actually compute a binary delta from one version to another, and then send only that pre-calculated kind of like binary delta to the device. So in the end, the device doesn't really need to kind of pick and choose what it does. It just receives the patch. It goes, okay, I can apply that. And typically speaking, the static delta updates are much, much more efficient. So you have basically a smaller size. It does depend on how you build your images, and there's a few kind of corner cases, etc. But generally, as a rule of thumb, they're much more performant. I'll show you some stats later on, which have some kind of like actual numbers to use in a real world scenario. But you can imagine that because the static delta, we're pre-calculating this difference between version 1 and version 2. What happens if I have version 3? So now I need to calculate the difference between, I have like n-1 different combinations that I need per release, which is kind of can be difficult to host because every time you release a version, you have to then calculate a static delta patch for each of the version combinations. There's ways that you could manage this to say, hey, we only support updating from this specific version to this. However, I think in a very heterogeneous fleet setup, that might not be practical. So it does add a bit of like server-side overhead that you'll need to kind of calculate more deltas. So it's not impossible, but there's a bit of like coordination on the server side, which is needed to tell the device what delta update do you need based on your context. So let's look at a few diagrams, and then I promise we'll go into a demo shortly. So I'm trying to illustrate the dynamic updates. So you can see, like, if we move up in the image, like this is the install process. So on the device, I start with, let's say, petition A. So this is my current petition, and it kind of has like chunks of blobs or whatever on the device already. Now, I actually want to apply this new image to the device. I want to apply this new image to get down to my new petition B. So I want to transition from A to B. Now, obviously, I could just download the whole new image, but again, that's huge. So 200 megs, maybe I don't have 200 megs in my mobile network connection. So I want to kind of only download the chunks that I need. So on the server, this is the single image being hosted. It has the whole image, but it includes an index file. So there's an updater on the device. So this will come into the solution kind of, who does this. Basically has to compare that index, look at what's locally available, and either copy from the previous kind of like chunk store, as it's called, or download from the internet, or download from the URL that's given. So you can see that this partition B is actually reconstructed from two different sources. So it's copying stuff locally, so that's not a download, and then downloading chunks. But you can see there's multiple downloads happening here, because each chunk has to be kind of like, because it's a binary chunk, needs to be, has a start from byte 0 to 100 or whatever. It needs to then do all these individual things. So because of all of this and the index, there is an overhead. So I haven't really visualized that mostly on the graph, just to keep things a little bit simple. But just think, for every kind of download you have also the overhead. And also if you have to do multiple requests, and you're using SSL, you also have those overheads. So it kind of adds up a little bit over time. Comparing to static updates, so I've tried to keep the same layout to also, you can play this later. It'll be committed to our demo repository, so you can also launch the presentation and then do this nice kind of, toggle in between the two. So with static updates, we're a little bit different. So instead of having, so we still have like partition A here, our current one, and we want to move to partition B, but instead of having a reference to the full image, we send it a image delta. So this only includes bytes that have changed, and obviously, there's a so they're mostly using a xdelta3 format, which has its own kind of like compression format and how it's stalled and does all of its binary diff magic. So what the updater needs to do is actually a lot less, because it just needs to do one download. So it downloads the delta file. And then when it applies this patch, so it has to know what state the partition A is in, because again, a delta is only applicable from a specific version to another version. So if you don't know the starting point, the delta will just spit out garbage. So the updater is kind of there to coordinate, going, does that delta file match my current kind of version, which is on the partition A? And if it does, it then applies the patch along with the existing partition to then generate the partition B. So these are no longer downloads because we only have one download here. So this is done in streaming. Again, representation is a bit difficult here. But in effect, it's basically doing copying, but in reality, it's the xdelta3 is doing this. And whatever the updater is just streaming the stuff to xdelta3 or coordinating the calls to xdelta3. So you can reconstruct that partition. So you have to do probably maybe a little bit more processing potentially, though it's probably on par with the previous one. But it's basically just kind of copying and doing, expanding that kind of patch. So you can imagine I tried to keep the diagrams very generic and just saying updater, but obviously you need some kind of technologies to implement and coordinate all these things. So in the AB kind of update worlds, there's 4 categories or like 4 kind of leading technologies. Yes, there could be a lot of different other ways to do this, but say like if you're looking for, out of the box kind of functionality, these are the main 4. So we have RAUC, where that supports dynamic updates, but not static. So it's pretty good, and it's a very nice solution. And it does a really good job at dynamic updates, but you don't get the full payoff of static, like with the reduced download size. With Mender, you have the opposite situation, that you don't support any dynamic updates. I'm sure you could probably implement it yourself, but who wants to do that? And then you only get static updates if you pay for a professional subscription. So again, not free. Rugix, previously known as RugPy, supports both, and that's kind of the feature I'll be demoing today. So that supports both dynamic and static. So you can get the best of both worlds, which is really nice. And also SW Update does support it because it's a very, but the thing is, it's a very low level kind of library. So it can do everything if you do the manual integration, which is, there is the main caveat. So I think there was a Reddit post yesterday about this and people were going, hey, you know, SW Update's also great, I can do this, but it's been on our to-do list because we haven't implemented it. So it just kind of shows that, yes, it's technically feasible, but then you're putting basically all the technical onus on the people integrating it. So, and if, you know, it's not a priority in the backlog or whatever, or you don't have the technical expertise, then it ends up not being implemented. So that's where out-of-the-box functionality is really, really a big highlight. Okay, so hopefully that was enough setup. Then a little bit of background on Rugix. So it's basically, you know, you can read the description here, but it's basically a tool set to produce Linux images and to perform over-the-air updates. So Rugix is actually kind of composed of like two different components. So previously it was kind of, let's say, communicated as one component, but it's now two individual components. So it was always two individual components, but I think users didn't really think of it as two different components. So you have one Rugix control, which is, that is the mechanism on the device doing the AB updates. So coordinating, you know, what petition do I go to, some state management, switching in between petitions, so you can do that after the fact and all that kind of stuff. And then you have the Rugix bakery, which is building the operating system images. So you don't need to use both. So you can just stick with Rugix control and not actually use the Rugix bakery. So, which is the case that I want to kind of discuss. So in previously mentioned, I kind of showcased the differences in sizes in between a Yocto-based image and a Debian-based image. So, you know, 200 megs to, let's say, 500 or 700 megs. So that is huge. So if I want to kind of, well, I know exactly what devices and I don't want to support generic devices, I want to really trim down this operating system as much as possible and only install what is needed for these devices. So I want to use Yocto, and Yocto is fairly, I would say, the industry standard for building the images. There's other solutions available, yes, but it is a very, very flexible tool. However, the good news is there is actually a way to integrate Rugix into Yocto. So Solidix provide a open source layer. So that's just a Yocto term to say, how do I install these things in Yocto? Which basically integrates Rugix and then also produces those kind of binary files to update and use the over-the-air update functionality. So that's the underlying thing to actually do it. The good news is we've integrated also in the metered edge, so that's the thin edge Yocto layer, to then also integrate Rugix within it so that we can also coordinate the firmware updates also from Velocity and have a seamless integration there. So this is the part that I kind of wanted to show. So again, images go down from 700 to 200, fantastic, because I can deploy it to small devices which might not have that much disk space available. And generally, if I have to do a full image update, it's smaller. So now we get into the nice bit. So the update takes a bit of time. So in parallel, I'll also kind of show you like peek behind the curtains and look at a little bit of like the bundle format, etc., for doing these updates. Okay, so here I happen to be using a Raspberry Pi 4, and I want to do an update. So I can already see, so we publish a bit of information about Rugix because maybe I want to say, what petition are we currently on? So I can see we're already on petition A, and the default petition is A, because I can also switch in between and say, I don't want to change the default petition. If I want to maybe test a new petition and then go back to the old one, you can control all this stuff. I can see it's using TryBoot, which is a Raspberry Pi 4 bootloader to facilitate the actual underlying switching of the petitions reliably. And I have some bit of like additional meta information about the image, which has been already applied to the device. So each image will have a hash, so you can uniquely identify it. So it's more like a real checks and balances kind of representation. You can kind of think exactly like a Docker container. It has a tag, which is kind of meaningless. Under the hood, it's really a hash, which dictates what exact image is it. So exactly the same concept here. But if I kind of want to see what version we're at, we can get the nice human readable version here. Just make that a bit bigger. So now I built a new image because Yocto also does quite frequent updates, patching for CVEs and whatever, like security patches. So I want to kind of update to the next version. So here I'm currently on the 1608, but I want to kind of move in the end to 1156. So there's been a week of development in between and security patches. So here you might notice this one is kind of a combination of the two. So this is just, at the moment, we want to improve that story and how can we, visualize this better and, facilitate the coordination of the rollout of Delta updates to devices. So let's skip over that topic. It will get better, yes. But here I want to select actually the Delta patch and then apply it to the device. To be honest, as a user, I don't really need to know it's a Delta patch. It might be helpful to know how big it is, but I'll show that shortly. So I install it, and then it'll go do its thing. So we can see here, that's nothing new. That's something we've demoed multiple times now. So we're currently on petition A, and so the update's going to be applied to petition B. It's going to do whatever it needs. It'll interpret that binary that it's been given and kind of automatically decide, is it a Delta update? Is it a dynamic update? Or sorry, is it a static update? Is it a dynamic update? Or is it a full image? And it will do the associated handling that it needs to do. So that's the really nice thing with Rugix. It just does it, kind of handles it for you, so it handles the complexity for you. So while it's doing its thing, let's have a little bit of a look at the bundle, what I actually sent. So here, this is the image, so updating from 1608 to 1156. So, date kind of timestamps in there as well. You can see that the update is 10 megs. That is absolutely fantastic. So the image is not 200. So if we look at I think that's the image. So we have the image here, which is 200 megs for the full image update. I'm only having to send the device 10 megs of that. The device needs to kind of coordinate and still reconstruct this second petition based on the current kind of state plus this patch. So it's a little bit more complicated for the device. But I mean, in the end, do you really care? I mean, it's the Rugix doing the heavy lifting or the X Delta 3 doing the heavy lifting. So it's quite easy. So Rugix coordinates everything. So, check the version and do all the state kind of management. But it just means that I've saved 190 megs in download limit, which is absolutely huge. So with saving the limit, that means that you can actually update things more frequently and react quicker to even do, like with the Cyber Resilience Act, where you need to react to new security notifications, which get kind of announced, and you need to then patch your devices, then the cost of that patch is considerably reduced. Because you don't need to send 200 megs anymore, you only need to send what's changed. Obviously, if there's a lot of changes, it will be bigger. But you can kind of minimize to only the bits which really matter for the device. So let's peek behind what's actually in. So you might notice that the Delta was a rugxb file. So what's actually in that file? So go here. I don't think I can make Finder any. Oh, I can. So within that kind of, I've expanded that bundle. And we can see it's composed of multiple files. So we have a manifest file, which then is something from Rugix, which basically says, what's within your bundle, what petitions are they, what is it? For example, is it a Delta update? What's the input Delta, etc., and what slot it gets applied for, and compression, and all these kinds of things. And then in the payloads, we have two components here. So we actually have two petitions included in this bundle, and both are compressed using X Delta 3. So they'll be doing a binary diff and then just producing that patch kind of file that X Delta 3 does. So we can see here, petition 1 is actually the bootloader, correct me if I'm wrong there, Maxi. But we can see here, so it includes like stuff like the Linux kernel and the device trees, etc. You can see it's already kind of finished. And partition 2 will be the root file system. So we can see the cost of the 10 meg, all of that is just root file system changes. So that means automatically shows me, okay, I haven't done any kind of like kernel changes. It's purely just stuff in the root file system. Yeah, so it's you can also kind of gain a little bit of insight, but I know ahead of time, this is only going to cost me 10 megs in download size, which is really nice. Yeah, so Marco, if I only saw the preview of the question, but I guess it was something along the lines like, what's the upgrade path? It's a very smooth upgrade path. So basically it just works. So yes, you will need to do one full image update before you have a Rugix version, which can do a Delta update, obviously. But after you do that kind of first update, then it should just work. So we can kind of define, it will automatically detect what's in the bundle and then apply it appropriately. So it's a very smooth transition. The only kind of caveat, which, caught me by surprise, if you flash a new Delta-enabled Rugix image the first time, you actually need to do one update via the OTA kind of mechanism, or like a local or whatever, before you can use the Delta updates, or at least the static Delta updates. So, but you can kind of work around this. If you're doing this device in the factory, you probably want to test whether the over-the-air updates actually work before you apply anything. You can also do it locally, etc. But yeah, I'm sure that story will also get a little bit better over time. But it's really just a once-off cost, which you can do in the factory and mitigate most of those problems. So while I was explaining, everything kind of succeeded in the background. So let's just kind of go through just to kind of see the sequence of things. So, we started the update. That's where I started talking and showing the bundle. It downloaded it. So it's actually downloading it via the Comvelocity local proxy. So that's provided by FinEdge to do all the authentication. It then, after it's applied it, we need to restart. So we're booting, then changing into the spare partition. So we're going from A to then B. So the device is then rebooted in this time. It's come up. So we're waiting for the network here. So it says, hey, the device has been restarted. Cool. I'm going to continue the workflow. So I'm currently in partition B, but we haven't verified partition B. So actually my default is still partition A. So this means if I were to reboot at this phase, it would actually go back to partition A, because that's kind of what you want. Before it's been verified, I don't trust that new partition. So it needs to go through the verification step to make sure it's healthy. So we then do some health checks to make sure, are you good? Can I change the default? And then when everything's okay, we do a commit. So saying we're happy with the state of the new partition. I want this to be the default partition. So then we log here, hey, the new default is B. So I've done a seamless AB update, cost me 10 megs, didn't need to do anything. Super, super nice. And then just to kind of, so I just configured my device to always upload the workflow file, because I just wanted to see if we could have a bit of a look at what was downloaded. I think it's downloaded. So here we have, so it's downloaded 100% of the bundle, but 100% of the Delta of the bundle. So that's only downloaded 9 or 10 megs. Perfect. So obviously you can't like pick and choose what bits it downloads from a already generated static Delta bundle. But you can see it only downloaded 10 megs, which is awesome. So for the comparison, I did kind of do this. So for that same update, I did both techniques, like going from a dynamic Delta update and a static Delta update. So we can see here that for the dynamic updates, because we're sending it we're making the full image available, and then it's up to the device side to then pick and choose, that from that whole total 191 megs, it only downloaded or had to download 27 megs part of that. That's still fantastic. So that's 14%. Cool. That's an incredible improvement. But it's not as incredible as static updates. So here, we only had to download 10 for the same change. So it shows, so if you're really, paying for bandwidth costs on mobile connected devices, then it really pays to, be able to support static Delta updates. So with the integration side of things, so at the moment, for the out-of-the-box kind of integration, the tri-boot is the only one, so that's specific to Raspberry Pi 4 and 5s. However, other integrations are definitely possible because it's more just, you need to kind of be familiar with U-boot and Grub and all these kind of bootloaders, that you can definitely do more integration. So if you already kind of have that experience, then it should be fairly straightforward. Or if you need kind of commercial support, so Solidix are also available, or other companies as well that are versed in embedded Linux kind of space. However, the good news is there's also planned features to make this upgrade path also easier from existing RAUC and Mender solutions. So to actually reuse the bootloader mechanism or the switching mechanism used by both of those kind of solutions. So this means that you could also, kind of frees you up for, again, kind of freedom of choice to even switch from an AB update mechanism to something else. So there was actually a POC done last night. So Maxi did some nice work, and I kind of tried to assist it to make devices available for him. So there's already a successful POC. We're migrating from both a Mender and a RAUC image to a Rugix-enabled AB update image. So I think that's an important fact, that because generally these AB update mechanisms are usually, once we've locked you in, that's it. So being able to be a little bit more flexible with, well, what happens if I want to upgrade from something else to something else, then having these kind of out-of-the-box migration strategies is a very, very attractive offer. And there's a few links to all of, like, the Rugix page. It might be worth noting that there's a nice blog post from Maxi, co-founder of Solidix and Rugix, to kind of go into depth a little bit about the efficient Delta updates and the comparison, and looking at, comparing to different kind of update algorithms and all this kind of stuff, and to also have a nice little cost calculator. How much money could this save me? Because that's also another important, which might not be known by a lot of people. So when you host a binary somewhere, generally the hosting costs for actually putting that binary something is cheap. What hits you in costs is download size. So the egress from those binaries. So if you have a 2 GB image, you pay quite a lot of money if you have 100,000 devices downloading that 1 gig image. So the egress costs can add up over time and become actually a very high operational costs. So if you can then minimize the download, it's not only the device benefiting from its kind of bandwidth saving, but you also have less egress costs. So it's a win-win. So I'd encourage you having a look through all of that kind of content. We will be adding a lot of this kind of documentation because it's still quite new. So we haven't kind of added it, hey, you can integrate all of this stuff. But if you're doing it, if you're in the Yocto space anyway, we've just added it as a new CAS kind of project. So it's really just a matter of, instead of using tej RAUC, tej Rugix, and then you get it. So it should be fairly straightforward to also consume if you're in the Yocto world. And it should also work out of the box already with the, so the tej, what's it called, the Rugix image. So it should also be integrated there as well. So that should also support it out of the box. But again, those are larger images because it's Debian based, nothing to do with Rugix there or Rugix Bakery there. It's purely just because, the base Debian images, or we're using Raspbian by default, are huge. So sure, you could probably do some saving somewhere else and cut down on the drivers, etc. But it just makes it a little bit more complex. Cool, I'll at least stop sharing so I can have a look at the channel, because I know there's a lot of content there, and then so I'll have a look if there's any kind of open questions. I guess will you release both complete updates and Delta updates in the existing Rugix repo? Yeah, I think that should be supported now. So maybe to make it clear, the implementation on the ThinEdge side was like 0.1% of the actual work. All of it is actually done by Rugix. So I think maybe the Yocto integration, okay, that took a little bit more time, and we were able to do a few PRs in the Meta Rugix layer to support more kind of Yocto versions. But overall, all of the work is just done by Rugix. So big shout out to Maxi for making all this possible and for free. Like no one else has been doing this. So that's absolutely amazing. All right, yeah, Maxi, you already answered the question. I should read. Nice. Yeah, so I know there'll be a lot of open questions. Feel free to kind of ping us on Discord or like reach out if you're a Comlossi employee on the ThinEdge user group or like space, Google Space, because I know it'll kind of like spark a lot of kind of conversation around and how do I do this and how do I build Yocto. We can definitely move and help you guys through that. But just for something I discovered recently when trying to build a Yocto image on a Mac, I previously said just don't try it, it's not worth it. It actually works now. So as long as you have like, I don't know, Lima and have a Ubuntu 2404 image, I was able to build a Rugix image fine, purely on an M1 Mac. So that is also quite nice. It takes forever. So, it still takes a good 2-3 hours, but at least it will give you the possibility rather than spinning up a AWS EC2 instance, which can cost you a bit of money in the end.